So this is the basic architecture of our live information management architecture, where you have the input events, external events coming in, and we basically listen to those events. These events are mapped to various systems like databases, networks, middleware, other databases, web services, all kinds of different sets of technology, VoIP or SIP servers, looking at various application events. And we basically are listing, basically these events are mapped according to the business definition or the business process that's being defined. And what happens is that when the event comes in, we are basically checking that event against the process definition. Now, if that event is not part of the process, then we flag that as an anomalous event. And we can basically send that alert to, we can actually block it, or we can actually send this alert to command and control for more actions. Now, the key difference here is that one of the reasons why we can do this is because we have to build a software language that could actually look at the graphical structure of a business process. It could actually read the graph from its causation, from cause and effect relationship. Where in the traditional approach and traditional software environment, software systems can only do data records. So this is why you have to be able to put the system data into some sort of a database system, and once that record's in there, then that record gets processed by the software. Where we have a language that can actually audit a single event on a graphical UML type process. It can actually see if that event is being followed or not. If it's not, then we can automatically alert. And the beauty about this approach is that it takes almost machine or CPU cycles to determine whether an event is anomalous or not. So it's not very CPU resource intensive. So then, in which case, you can actually monitor thousands and thousands of instances of business processes and see if they're anomalous or not. So it's not very CPU intensive.